include font files in CSS and have them load by the browser along HTML and use them to display. And that actually was a very big step forward, because browsers, web browsers, evolved very quickly. So, and also it was a kind of clean break, an ability to do certain things in the browser which would take years to be adopted on sort of desktop platforms, where you have old apps that have certain assumptions, and working around these assumptions, like how large can a font family be, is difficult, because these apps are old, they have these menus, and changing them, all of these apps is really difficult. So most of these new things actually happen primarily on the web, and only slowly, if at all, get adopted in apps, in programs that are used otherwise. And of course, tech is sort of to some extent, I guess, affected by that. I'm really looking forward to Hans' talks about variable fonts. So he will show you what he implemented, and I'm going to talk a little bit more about what it all is for and how it came together. So, this is one of the, ideas that could be done with glyphs that are more than one color. And of course,
Adam,
oh, right. Well, okay. I'll just. Oh, dear. Okay. This is a sort of little table that it should have two more graphics, but somehow it didn't work. This is the big point, that we have TrueType, OpenType, all these formats for years had just monochrome outlines, right? You had glyphs that were made from Bezier curves or B-splines, either cubic or quadratic, and defined sort of the border between the printed area and the non-printed area, so between sort of black or white, but of course it was more like opaque and transparent, so the black could be then defined as fill this with any color, not necessarily black. So that was the monochrome fonts, and in the OpenType terms, OpenType and TrueType, because they actually sort of originate from the same stem, which was TrueType. The TrueType or OpenType font files are split into the so-called tables, which are just chunks of binary data, and each of them has this 4-letter tag, and these are used to sort of identify these sections and their purpose. So the glyph description, the description of how each glyph is constructed is stored in the glyph table for monochrome fonts, and that is that's the original TrueType way of describing the shapes using quadratic B-splines. And then there is another table, CFF space, actually, because it's sort of 4 characters, and it stands for compact font format. It was an invention of Adobe as a sort of compressed version of PostScript Type 1, which they developed to put fonts into PDFs. And when Microsoft started talking to Adobe about OpenType, so an ability to put cubic PostScript type outlines into this. Oh. They basically came up with CFF. CFF was this standalone font format in a way, which could live by itself. It had all the information that were needed as a font. And that was placed into the structure of the TrueType tables. So some data was duplicated, but it sort of worked. CFF is a bit nasty and weird, but it's sort of like a, compressed PostScript in a structure that is not like PostScript at all. So it's a bit awkward. But it's been there since 99 or 2000. So glyph and CFF, or as people sometimes say, TrueType flavored OpenType and PostScript flavored OpenType. That's been the two ways to store monochrome outlines. And then in about 2013, this notion of emoji, the colorful little graphics that sort of work as characters, came up. The Unicode Consortium has standardized a large chunk of them, which were proposed by a Japanese telecommunications sort of body. But then this question was, well, they're supposed to be colorful, so how do we put them into fonts? And sort of all these operating system vendors needed this more or less at the same time. And in that case, they started proposing their own formats. So Apple was the first that implemented these emojis as fonts, using their own extension to TrueType GX called SBIX, which wasn't published at all. And they used PNG images that are sort of stored in a certain way inside the font file, and then you also use the glyph table, which doesn't have any outlines, but it's used to calculate the metrics. And the way it works is basically the layout engine that doesn't know anything about PNGs uses this font, including the glyph table that doesn't have any outlines, to do all the layout, basically to lay out the boxes, using the same technology that they had before. And once the boxes are done, then the rasterization process, which normally would fill in the outlines, actually reads these PNGs and puts them where appropriate. So it's actually, in a way, quite clever and simple, and also works the same way when this is serialized into the print stream, into a PDF, where this sort of a fake font, which just has these empty glyph slots, is included, so you can, select the text, and the width of the selection box for every character will be correct. And then sort of the PNGs are just placed into the PostScript stream at the right position. So the process hasn't changed much, but it sort of is embedded originally for emoji. Some people start doing, multicolor fonts, but it hasn't really caught up that much. But that was SBIX, that was the Apple table. And at the same time, because they kept this spec private, Android also needed emoji. So they actually wanted Apple to publish their spec, but Apple wasn't really interested at the time, and they said, well, yeah, no, there's some, whatever, Apple had this weird, super secret, so even that was super secret, even though it was a trivial structure, but, so a team of font people at Google, mostly Begdad Esfabot, used a different version, sort of ways to embed bitmaps that already existed in TrueType and OpenType, and added PNG support to it. So CBDT and CBLC, there are two tables. They're also based on PNGs, but stored differently than this SBIX stuff, unfortunately. Microsoft, for Windows 8.1, sort of silently did their own format called Color and CPAL, which Color is a table that takes monochrome glyphs, glyph or CFF, and sort of has this information, staple these glyphs on top of each other, and give each of these glyphs a different color. So basically it's it's just a way of layering these glyphs. These are the sources. They're drawn, you know, if you have like a color font with an emoji and you have a smiley, then basically you have one bit in the glyph table that is just the mouth, eyes, the inner portions of eyes, the face, and then in a color table it is said, okay, take this glyph and make it yellow, and then take these two glyphs, make them white, these should be black and this should be red. So it's just for flat colors.
Not to be bitmaps?
No, these cannot be bitmaps. And the CPAL table is basically, because the color table does not encode the actual color values, it just encodes references to a palette, and then the CPAL table has this palette, so it's the color 0 is this one, color 1 is this one in RGBA, and there can be multiple palettes. So basically, there could be different color sets for a particular font, and that was implemented in Windows 8.1, and then Microsoft sort of implemented it in Windows, published Windows, and said, and by the way, we're putting it into the OpenType standard.
How open is that?
Yeah, well, it was still sort of the older way of doing things. And sort of at the same time, I proposed this idea to a working group that we should put SVG data into OpenType, because SVG is quite powerful. It basically has, you know, bitmaps and vector graphics. It has complex fills, gradients, and anything you want. Basically, SVG was developed at Adobe from the PDF or PostScript graphics model. Adobe did a lot of work originally on the web consortium. Then they bought Macromedia, so they had Flash, so they had to drop SVG as this open thing, because it was decided that they will now market Flash. But Apple did not support Flash, so basically Flash was kind of buried, and now they came back to SVG. So the people at Adobe were very enthusiastic. We formed a working group within the W3 consortium, and we kind of developed this structure for the SVG table. So we have these different proposals. This CBGT by Google, very simple and quick. SVG, quite demanding, because in order to support this, your app needs to have a full SVG renderer, which is a complicated thing. The color CPAL table, the Microsoft proposal, it's of limited use because it allows you to only have these flat graphics, so it forces to use a particular style. And then the SBITS table, well, once these formats came up, I realized I started sort of corresponding with the different people and from these companies, and kind of made at least okay, let's try to kind of use at least some bits that are the same or could be reused. So for instance, the CPAL table that Microsoft proposed, I thought that's a good idea, so we decided to also use it for the SVG. So the SVG, you can store explicit colors inside the SVG tables, or color indices that refer to the palette, because the palette idea was great. Apple, at some point, when these proposals came up, said, oh yeah, actually, no, we actually decided to publish the SBITS table spec, because, well, why don't you use ours? And, well, it's too late. You like, a year ago, you were like, whatever. So these 4 things were on the table.
Just a question, OpenType is still officially an ISO standard, or how does...
Well, that I can comment on it later. But
question time.
In the end, all these 4 things, because they were implemented in different browsers, etc., were all put into the OpenType spec. So the OpenType spec, in the standard, now has 4 different ways to express color glyph information, and you can, well, choose yourself whichever suits you. It's ridiculous. It was just this old way of thinking, each company doing its own thing. But altogether, well, it's, when it comes to just usability or, potential use, this is something that I asked Łukasz Dziedzic to do. He used Blender and his FF font to sort of create this font, which really works like a font. It works in macOS 10 because it's the SPIX variant. You can, select type. It's great.
Full kernel.
The kerning, I didn't put kerning in there, but it can have kerning, of course. It was just it was just an experiment, so it's not a released font. This is, another example what, shows up on my iPad, because the iPad also supports the SBICs. So this is the font selection, and this is one of the fonts that I can type in any app that supports font selection on the iPad or the iPhone. So it's not just for emoji, of course. The company I work for, FontLab, we created this free little app called FontLab Pad, which kind of, if I'm working in something like Photoshop, I can run FontLab Pad, I can open a font, type in some text, I can set the background of the window of FontLab Pad to transparent, so I see whatever I have behind. And this FontLab Pad supports all of these 4 color formats. So then I can basically work on a mockup, and then I just I save as a PDF or SVG or PNG and put it into my real app as a graphic. So it's good for short headlines, for, of course, it's not like the live typesetter, but it's sort of like a little helper that is useful for testing and for this kind of, because actually, multicolor fonts will probably not be used as body fonts, more like for decorative effects. So, these are some people have on something like my fonts, where commercial fonts are being sold, are selling that they're not selling these ready multicolor fonts, because the currently no font distributor sort of supports this technology yet, but they sell the so-called layered fonts. So basically they sell separate fonts, each of them being ready to be used as a layer, and then you as a user are supposed to sort of compose them, color each layer differently, and there are quite a few of such fonts. This is another one. This is something that some designer made for FontLab. This is a font that Łukasz again made. I convinced him. He released this typeface called Ringo, which is a regular monochrome font, and I said, "Oh, come on, but just do this." So then he spent some time in Blender and made this. Because we came up with this name Ringo, so it was Ringo Blingo, bling,
Z Blenderze zrobione, tak?
So yeah, so this was done using Blender and then Bitfonter, an old app from FontLab, which and then TransType 4, which kind of allows you to generate then from some other sources these fonts in the color font formats. And then this is an early screenshot of then called Victoria 1.0. Now it's called FontLab 6. It's still in development. It's our font editor, commercial font editor from the company I work for, and basically the project I've spent most of the last 5 years on, which supports all these color font formats from the very beginning. Okay, so that was Łukasz Dziedzic and David Bezo. That was basically the bit about color fonts. And, well, what about variable fonts? So variable fonts are, this is David Bello and Łukasz Dziedzic, two, type designers who sort of see and think in multiple dimensions. This is more like what I think their minds are like. And these are some graphics things that Łukasz makes to help visualize how interpolation in multiple dimension works. I still don't. I get confused, but yes. So I'm going to explain how these variable fonts work. So we have the concepts of masters and axes. So these are masters. This is FontLab Studio 5. It's our old font editor, still used by many people, and we have these sliders. We have the axes and the masters, and well, a master is basically a particular drawing for each glyph, which has these outline points, Bezier points, arranged in particular positions. So this is one master. This is another master. This is another master, and so on. So in this particular font, this is again FF Clan Serif in development by Łukasz Dziedzic. It has 8 masters, and this is actually made using the concepts that were behind the multiple master technology by Adobe, which I'll explain briefly in a moment, which are slightly different from what we have in these variable fonts today. But the concepts are translatable. Basically, the variable fonts are a bit like a superset of multiple master. In multiple master, because we have 8 masters, we have 3 axes. So if you look at the points, basically this is, the whole idea is that the outline points, there is always a fixed set of outline points. They only differ in their positioning. So what happens is linear interpolation is basically each axis has a certain value, let's say from 0 to 1000, and the coefficients are made from them, they're added, and you get the final positions of the points in an interpolated instance. So because these are 3 axes and each, well, I'll show that in a moment, but this is basically, this is the process. So this is the process in how it sort of internally works. The points are always the same, or, yeah, they're the same points but at different locations. And of course in the final rendering you don't see these overlaps, so you just get the interpolation effect and the ability to select any of these intermediate variants depending on how many axes the designer has created. Okay, so in multiple master, if I had 1 axis, I needed 2 masters. So 2 sets of positions for the outlines, for all the points on an outline. And yeah, and the number of required masters is basically 2 to the power of n, where n is the number of axes. So if I have 2 axes, I need 4 masters. And if I have 3 axes, I need 8 masters, which is what you saw in the clan example or clan serif example. And if I have 4 axes, I need 16 masters and so on. And that's actually, I think, the top limit for MM, is I think 4 masters. So that's an old technology that has been in use in one way or another for a long time, because Adobe has shipped some multiple master fonts in, well, early 90s. Then they have basically stopped selling them, but this paradigm of designing typefaces or fonts has prevailed in font editors and in font design applications, and then basically designers would draw like this, or like what you've seen in these animations, and then produce single instances and sell or put to the market a collection of these assorted instances, so to speak.
Your Ringo Blingo with these 4 axes or 3 axes?
No, the Ringo, that was clan serif. Ringo Blingo is color, so that's
But if you would make it variable,
that was done like in PNG. So PNG is not. It's not outline based. Yes, it's.
But
So
if you would make it outline based, would be 3 axes or 4?
that's difficult. Difficult to say. I think it's basically it's the amount of work. I think it would be more like 1. Basically, it would only vary probably in weight, maybe in something else. So yeah, so this is of course the idea. We have the 2 masters, and we can generate any interpolated instance. If we have 2 axes, we have 4 masters, the masters in MM needed to always be at corners. So basically, that sort of required a very particular mindset. Like basically, like what Łukasz, you can see these multiple dimensions because you're trying to design this, but actually you can manipulate only those four things. So it's like, it's like being at four corners and trying to sort of arrange the table that is supposed to in the middle using some ropes, and you have to coordinate all four people to do this. It's or 8 or 16. It was challenging, and then something like this would be typically for three axes. So very early on, in like 91, at Apple, during the font wars, there was this discussion about having something like multiple master, but for TrueType. And that was part of the TrueType GX effort. It was called Descartes originally, and it was a project to sort of make TrueType fonts variable. It was a cooperation between Apple and the Font Bureau and people like David Bello and also Sampo Casila, the originator of TrueType, and also Mike Reed and some others worked on this. And basically, this Descartes was, the idea was that rather than using these corners, you would, each axis would have, basically all axes would have a sort of an origin, and that origin would be the actual design, the one sort of set of glyphs that don't have any variations. And then along the axis, each axis, there would be a space from actually -1 to +1, where you would define at the endpoints of this axis deltas, so movements of the points. So rather than encoding the absolute coordinates of the other one, you would encode just relative coordinates from the neutral master. And also, it allowed you to add additional sort of masters at any intermediate position between 0 and 1, and define a start, an end, and a peak where that part takes part in the interpolation. So you would have basically, if we just had one axis 0 to 1, that would be the neutral master. Then another master might be somewhere here, and it would say, okay, so I'm using this at 100% here, then I'm starting using this one, stopping using this one, and then starting using the one at 1. So that at that point, this one, the coordinates encoding here are taken at 100%, and here at 0. Here they're taken at 100%, here at 0, and somewhere in the middle they're mixed. And that addition takes place across all the axes. So, and that's basically, the result is, vector addition. So if I have my neutral master, and then I have some coordinates deltas encoded for one axis, and then some other coordinate deltas in another axis, and I'm selecting across those two axes, then basically the points move first to the coordinates, or by the amount, they move by the amount defined in the first axis, or the coefficient of thereof,